Hi everyone, we are from Group 4. Today we are going to present the proposal report of the Integrated Design Project 1. Our project title is Solar Powered Ventilation System with Temperature Control Technology. So here is the organization chart of the Group 4. Professor Maria T.S. Dr. Tan Wei Hong as our mentor, I am Tae Zong as the group leader and also the first presenter. And the second presenter is going to Anis Shafika binti Abdul Rahman. The next one is Muhammad Alif Haikal bin Muhammad Ghazali. And then fourth presenter is Noor Alia binti Azman. And the last presenter will be Tarani Shwaran anak lelaki Ravi Chandran. So here is the table of content of the presentation for proposal report, which include 8 segments. We will go through the segment one by one from our presenter after this. I will be present for the first segment, which is project introductions. What is ventilation system? Ventilation system comprise component design to circulate and exchange air within an enclosed environment. The main purpose of the ventilation system is minimizing indoor temperature, provide fresh air, remove stale air, control temperature, and maintain indoor air quality. From the figure, we can identify that the average weekly temperature of the Malaysia weather. Nowadays, Malaysia experiences high average temperature, which leading to heat-related issue. As the information, the existing ventilation system have their limitation, which has high energy use and require regular manual maintenance. As a solution, solar-powered ventilation system with temperature control technology offer a sustainable and cost-efficient solution, which also enhance the system capabilities. So next one is IR 4.0, or also known as Industrial Revolution 4.0 and SDG elements. IR 4.0 is the technology that we develop inside the system to make the system become more smarter. The IR 4.0 we include for the project development is solar panel and temperature sensor to enhance their performance, efficiency, and reliability, which contributing to the advancement of renewable energy and environmental monitoring. There are two SDG. For the first one is SDG 3, ensure healthy life and promote well-being for all at all age. And next one is SDG 12, which responsibilities encompass maintaining compliance with international and local standards to ensure safety, quality, and environmental sustainability. So next one is the problem statement. So the main problem statement is Mazda School has inadequate ventilation causing poor indoor air quality and discomfort in the cooperative room. This lead to health issues like respiratory problem, fatigue, and reduced cognitive function for the student. So the main purpose of the ventilation system aim to improve air quality and create a healthier, more comfortable and environment in the cooperative room. Last part from me is the objective and scope. There are 3 objectives, which is the first one is to implement a solar powered ventilation system with temperature control technology for enhancing indoor air quality and provide a comfortable environment for the students. So next one is to achieve energy efficiency and cost saving by utilizing solar power with intelligent temperature control feature. And the last objective is to promote sustainability by reducing carbon footprint, leveraging renewable energy source, and optimizing energy usage through temperature sensing and control. The scope of the project is developing a solar-powered ventilation system coupled with temperature control technology for the Mazda School to improve the quality of indoor environment, which is in the cooperative room. So next one is include a feasibility study to determine the energy efficiency, performance, and cost effectiveness. So the last scope is comprehensive recommendation and guideline will be provided for the installations, operation, and maintenance of the ventilation system.
Benchmark is a process of identifying, analyzing, and implement it to improve the performance. So we have 3 types of existing product. The first one is solar panel powered attic fans, solar powered wall vents with fans, and multi-cellular solar powered ventilation system. So for the first is solar panel powered attic fans. It is to reduce the indoor attic temperature and moisture. The advantage is to reduce the heat buildup and lower the energy expenses. And the disadvantage is the performance can be affected on cloudy days or also during the nighttime. So the second is solar powered wall vent with fans. The application is it is suitable for the garage, sheds, and the small spaces. The advantage is it is much easier for the installations and faster than roof-mounted attic fans. The disadvantage is it has a lower airflow rate compared to the roof-mounted attic fans. So for the last is solar-powered wall vent with fans. It is suitable for the large attics, workshops, and commercial spaces. The advantage is to reducing the heat, moisture, and improving the air quality. The disadvantage is it is much expensive compared to the others.
For the market survey result, there are a few questions that was widely distributed, and there are 50 respondents that answered the questions that came from different range of age and also educational background. As you can see in this slide, there are 3 questions over here, and I will randomly explaining a few questions. For this slide, we can see at the question number 3 states, the survey state that solar powered ventilation systems are environmentally friendly. For this statement, there are 28% that does strongly agree with the statement, and also lesser than that, there are 14% that agree with the statement. Over here, for the question number 4, it states that temperature sensing technology reduces the requirement for manual adjustment and monitoring of ventilation system. For these questions, as we can see here, 24% strongly agree with our statement and support our product, and also 15% agree with it. For the fifth question, as you can see over here, it states that temperature sensing technology can significantly improve the efficiency of ventilation system. From the pie chart itself, you can see that there are 21.42% that will strongly agree with with that statement. And sadly, there are 2.4% that will strongly disagree. The next question is states that solar-powered ventilation systems offer affordable long-term cost saving. And from this statement, as we can see over here, there are 30% that do agree with our opinion. There are 3 questions that was distributed, as you can see. Question number 7 states that solar power ventilation systems are reliable and offer consistent performance. And from this question, based on the survey result, we get 37% strongly agree, and around 14% agree. Question that is, what is best dimension that you think is suitable for the ventilation fan in the cooperative room? There are basically, as you can see over here, 18% agree with the stated size. Next, we move to the question number 11. 26.52% agree that the temperature range that was considered comfortable for indoor environment is from 25 degrees Celsius to 28 degrees Celsius. Okay, and lastly, we have a suggestion question. For question number 12, we basically asked the respondent what are there any suggestions that they will give us for us to develop more useful product, and also a product that will fit their criteria. And there are a few opinion over here. It says solar power will produce minimum value of power source. So they suggest us to do some research for the ampere and power that can be produced by one solar panel.
So next we will talk about customer requirements. So from our market survey, these are the customer requirements that we managed to obtain. The first one being it should be environmentally friendly. Second one, it must reduce the requirement for manual adjustments and monitoring. Third one, it should be technologically advanced yet high quality. The fourth one, it must be affordable yet lightweight. And lastly, it should be reliable and offer consistent performance. So the values here are based on the results we get from our market survey, with the being the most important one are the strongly agree and agree parts, which will later contribute to determine the importance weight factor for our customer requirements. So as we can see here, the customer requirements D having the highest value of 5, and as well as customer requirement C having the least value, which is 1. So moving on to our next slide, we will talk about engineering characteristics. So engineering characteristics are determined based on the customer requirements. So the first one we have energy efficiency. The second one we have the automated capability. The third one is the sensitivity of control system. The fourth one is weight optimization, and the fifth one is the material reliability. Moving on to the streamline HOQ. What is HOQ? HOQ is or known as House of Quality is a method that we use in order to determine the rank order of our engineering characteristics. So from this table here, we can see that customer requirements, important weight factor, and engineering characteristics are all present. So based on the calculations that we make from this table, we can determine the rank order for our engineering characteristics. As we can see here, the most important one should be the weight optimization that rank number 1.
Now, I would like to brief about preliminary product design specifications, which is known as PDS. So there are about 6 type of PDS. So we will look about the first one, which is product identifications. So there are about 3 types of product identifications, which is known as product brand and model. Solar powered ventilation system with temperature controlled technology. Another special features is solar panels temperature sensor technology and also automatic indoor temperature detector. The third is service environmental, designed to withstand environmental factors such as temperature and humidity. Add another PDS, which is market identifications. So the first is target market and size, includes educational institutions, commercial buildings, and residential homes with an estimated market size of 600,000 units per year. Another is market demand, high demand for energy efficient and automated ventilation system due to increasing awareness of environmental sustainability and energy savings. Again, competitors, SolarFlow, EcoBreeze, and SunVeg. And also marketing strategy involve online marketing campaigns, partnerships with relevant organizations, and emphasizing the product's unique features and advantage over competitors. Physical distribution. So, external dimensions. The ventilation fan comes in sizes ranging from 300 millimeter by 300 millimeter to 340 millimeter, and also 340 millimeter. So, about the design constraints, it operates efficiently with the provided solar power. Temperature sensor should be accurate and capable of precise climate control to maintain the desired indoor temperature. The fourth PDS, which is financial requirements. So about the pricing, cost per unit estimated at RM300. Proposed retail price is around RM450, offering seasonal discounts. And the warranty is about 2-year warranty on parts and labor, also 10-year warranty on solar panels. Return of investment, 18 to 24 months based on energy savings and reduced maintenance costs. As is life cycle targets. So useful life and shelf life. Useful of the product is around 10 years and the shelf life is about 1 year for storage. So the operating cost is estimated about RM200 per year for maintenance and electricity. End of life strategy, the ventilation system components are designed to be recyclable. About the social, political, and legal requirements, which is safety and environmental regulations. Ensure system design and installation do not adversely impact the existing building structure of infrastructure. Intellectual property. The design and technology used in the solar-powered ventilation system are proprietary and protected by intellectual property rights, including patents and trademark.
In conclusions, the solar-powered ventilation system with temperature control technology provides a sustainable and effective solution to the inadequate ventilation issue at Mazda School. By improving air quality and circulation in the cooperative room, its aim to enhance students' well-being and create a more comfortable environment. That's all. Thank you.